So if you see here, the users sitting behind the core routers, if he wants to access Google server, he have two paths. One is over this, or he can take this path. Okay. So you have multiple ISP. Let's say you have the primary ISP on AT&T, and you have the backup ISP as well, which is on Vodafone. For some reason, your primary link is fluctuating, and you don't want to send your packet towards this, right? So there is the scenarios. These are some scenarios where you would like to manipulate. Okay, you don't want to shut it down, because it can improvise, or it can, how will you test it if it's coming back, or it has been rectified, right? So you cannot shut it down, but you can manipulate the attribute so that this doesn't go over on this. Instead, it takes this path. Okay. And to achieve these kind of path manipulation, we deal with the attributes. Okay, the BGP attributes, and this is the pattern that BGP checks. It will first check with weight, it will check local preference, and so on. Okay, so as I told you, by default, let's say we don't have any attribute, or we are having all default attributes over here. Okay, so the last one would be router ID or neighbor IP, which is making the decision. But for some reason, let's say primary is fluctuating and you just want the secondary link to be taken up. So in that case, as I told you, you have inbound traffic manipulation and outbound traffic manipulation. Okay, so this inbound is nothing but traffic that's coming in, and outbound is something which where the traffic is going out. Say for example, the users over here. Okay, let's say they are some non-technical users, and they need only a low number of internet, so we can give them the backup link. Okay, we can give them the backup link. So in such cases, what I need to do is I need to see my topology. So in this case, weight is not very much important. The reason is this attribute is local to the router. In this case, I have two routers, right? So if you remember, in my previous class, I considered weight. I showed you some GNS example. I also gave you one practical lab so that you can practice weight. Okay, so weight is a scenario when you have only one router, and you have, say for example, this one. In this scenario, yes, you can make use of weight. You just have to you just have only one router. You can change the weight value, and you can just manipulate. You can just say that to consider this, not this. But when you have two routers, weight is not something that's gonna help you to manipulate the traffic. Okay, because weight is just locally significant. So if you configure something on this router is not going to understand what is that. So what is the next approach in case of let's say if weight is not something which is going to help me? So what is the second approach? So I have mentioned you. So if weight is not going to help me, I have local preference. That's my alternative way. Okay, local preference. So what are local preference? So local preference is again another attribute which is used for outbound traffic. Okay, outbound in the sense the traffic that's going out. So I can either take this, or I can take either this. But let's say I don't need this path, I want this path. So in this scenario, I can change the local preference. Okay, I can just change the local preference. But on what basis are you changing? Is highest preferred or lowest preferred? That is something which you need to know here. So in the case of weight, it was highest, and in the case of local preference, it's again highest. By default, it's going to be 100, Okay, by default it's going to be 100, so you just need to make it 150, whichever router you want to be considered. Let's say this is the default route, and for some reason you don't need this, so you just have to change the local preference of this router to 150, so that the traffic now start moving on this direction. Okay, what kind of attribute is it? It's a, so where did I write it? So okay, I think I have written on below slide. Okay, so it's a well-known discretionary attribute. So we have four types: well-known, mandatory, well-known discretionary, and optional transitive, and optional non-transitive. So local preference is an example for well-known discretionary. Local preference default value is 100, but that's what I said, you just have to increase more than 100 so that that router gets taken up. If you see here, you had three routes. Out of three, two of them have some value of 100 and 100, whereas one of them doesn't have any value. It's nil. So the reason is these local preference are AS based. That means route inside a single AS will be given a tag of 100. If a route is learned from outside AS, then the local preference will be not transferred. Okay, so AS or the local preference is significant to one AS. Okay, so let me be more specific. Let's say this is AS value 65,000. So the local preference is significant to this autonomous system. So any router, BGP routers, will have a unique local preference. But if some route is coming from outside AS, then that's not getting considered. So you are gonna see a blank space. Okay. What about weight? Weight is just router significant. Okay, it's just going to be within a router. So do you think in this autonomous system, if I have 10 BGP routers, uh, as I told you, I like regards to preference, local preference, do you still think I can make use of weight and manipulate my outgoing traffic? Yes, I can still do, but the complicated challenge here is I have to set the weight on all the 10 routers. Now that's something which I don't want to do, and alternatively I am preferring local preference, which I just need to do on one router which I want to prefer, and they are gonna be carry forwarded automatically to other routers. So who is going to carry? It's your IBGP. Okay, so one work of IBGP is to carry those attributes between all different BGP speakers. Okay, so router where we configure BGP are also called as BGP speaker routers. Okay, fine. What else here? So it says it's going to stay within a local autonomous system. As soon as eBGP concept comes, your AS or your local preference is gonna get removed. Something like this. Your AS or as soon as two different AS communicate, local preference is getting removed. Okay, and local preference is something which will span entire autonomous system. Okay, entire autonomous system between or across all the BGP routers, local preference is gonna be getting spanned up. It's not limited to local router, something which was in the case of in the case of weight. Okay, well, so what is the configuration line? It's just one single line. Okay, you go to router BGP, whatever autonomous system ID you're making use of, and you need to set this attribute called as BGP default local preference and set 150, because 100 is default, so you have to set one additional or whatever you can. Okay, so by doing this, Okay, so by doing that, you are changing the local preference attribute. And why do we use local preference? It's for outbound traffic. Okay, the traffic that's going either on ISP 1. So let's say this is AT&T. Okay, and yes, so someone who doesn't know how to change the icons, you just need to right click on them. You just need to click on symbol. Okay, and then you can just drag and you can just bring any of the icons. It's very simple in GNS, something like this. Okay, similar way I can also go and right click, something like this. Okay, so now it's little bit easier for me to demonstrate. Okay, so let's say my traffic could go to AT&T or otherwise towards Vodafone. For some reason, I don't want my traffic preferring AT&T. I need Vodafone. So what I do is, since I know local preference is 100 on both the router, I'll go to this C2 and I'll say the local preference is 150. So my traffic will now automatically start considering this direction. This will not be taken up. Okay. So this is for outgoing traffic. A similar way, let's say the traffic just went on, and while the return traffic, or the traffic that's coming from the Google server, so this is the end to end connectivity. Okay, so let's say the traffic that's coming from Google server, now it can take either this router or it can take this router. Okay, depending upon the ISP. Now let's say intermediate path, we had a serial link. Okay, so my BGP is not going to consider whether it's serial link or whether it's a giga ethernet link. It's me who has to modify the attribute. If I don't want this link, then I can do some changes so that my incoming traffics can be modified. And for incoming traffic, what are the attributes that are responsible for incoming traffic? So for incoming, you have AS path. Okay, you have AS path and you have MED. So I have also mentioned what are these things. Okay, so what is AS path? So AS path is nothing but, so whenever your packet is gonna travel across the AS value, so let's say the traffic is going on in this direction. Okay, let's say the traffic is for 8.8.8. So what happens? Your traffic get tagged up with a autonomous system or AS path. So the phi gets added up. So once it hits this router called as PE3, now it's gonna add its AS value. So 8.8.8.8 has 5 and also gets added up 4. Okay, the traffic that receives on AT&T and AT&T is starting to forward that. So now that traffic would be 5, 4, 2, and then over here. And once it comes over here, it's gonna add its own AS value. So now it would look like 5, 4, 2, and 1. Okay, so AS path is nothing but the prefix that's traveling across the AS values, different AS. They are gonna add their AS values. The reason for this is to avoid loop. Okay, so to avoid loop, I don't want my traffic for some reason goes to this and then re comes, or it just come back to me. Okay, so so to avoid looping, so in this scenario what happens is, let's say 5 4, so it was 5 and 4, and if the traffic for some reason going back to the originator, so this is going to discard that, because it see that my own as value is already been added, so I cannot accept any traffic which has my own as value. Okay, so that's how your as path is gonna help to avoid looping. Okay, so in a prefix you will only see one single copy, you will not see any duplicate. Okay, so in my scenario it will be 5 4 2 and 1. This will be my traffic, or this will be my as path. Now which is preferred? Let's say I had 5 4 2 1, and let's say I had some shortest value 5 2 and 1. Okay, uh, not in this, but let's say this was whole complete single as. Okay, so the traffic which went from this side, it got 5 4 2 1, 5 4 2 1, and the traffic that is taking up this path has 5, and I, as I told, this is a single as value, so let's give it as 3. Okay, 5 3 and finally 1. So which as value is preferred? It's the shortest value is preferred. Okay, so when you have as values, or when you need to manipulate the incoming traffic, you will have one of your attribute called as as path that will help you. Okay, so it's the fourth in number. So let me go back to that flow chart so I can show you where does this as path stands. Okay, okay, so let's say weight was not modified, so weight is not going to be a decision maker. Let's say local preference is also not been set, so that's also not a decision maker, and so on with originate. Now it's your fourth attribute, that's as path length. So the shortest is preferred in this case. Okay, and I have also mentioned the same over here. As path shortest is preferred. And why do we need as path? It's for your incoming traffic manipulation. So if I show you, or if I read out the points for as path, so it is the fourth BGP attribute. It's a mandatory attribute, describes path taken on the way to destination. Shortest is preferred. It's a well-known mandatory type. It follows the order list of ASN. So wherever your packet is flowing, you will see the AS value getting added up. The main purpose of AS path is to avoid loop. So AS path is used in the case of eBGP loop avoidance. Okay, eBGP loop avoidance. What about iBGP? In the case of iBGP, you have concept of full mesh or route reflector, which will help you to avoid looping. Okay, so in the eBGP, it's only AS path which will help you on avoiding loops. Yes, they look little less attractive because you will see a bunch of values getting added up, but yes, that will help you to understand how is your traffic flowing as well. So if you see here, this is getting added up, local preference. So this says that it was coming from 65,000 AS, and now it has received on the local AS value. So this is something from outside AS, whereas these are two which has originated within the same AS where I captured this output. Okay, so you need to know from the CLI point. Okay, because BGP is all about CLI. It's not a graphical that you will get a all the output in a very human readable option. So you need to know those tables and what does it says. So add own AS number. So the multiple times, so the AS path becomes longer. So this was regards to the AS path. Okay, and this topics, the 2 points, are for regards to the manipulation. So how am I going to manipulate, or how am I going to manipulate the AS path and bring up the path selection? So let's say by default my incoming traffic will taken up this path. Okay, so I have 5. So let's say traffic originated from here towards this loop back. 101 101 101 dot 1. So I have 5 getting added up, then it moves to 4, 4 gets added up, then it moves towards 2, and then finally it goes towards 1. For some reason, as a user, I don't want my main incoming traffic to be over on AT&T. Okay, I want it to be Vodafone. So for incoming traffic, as I told you, AS path is the simplest option. What I do is I'll prepend extra AS values, dummy, I mean to say logically. Okay, not something I am going to increase by taking up more ISP or something. What I can do is I can introduce some dummy AS values. So I'm going to introduce some AS value. Okay, so I say AS value of 100 is added up. Now what happens over here, you have one more tag started coming up with AS 100 value. Okay, now this automatically becomes the second path, not the best path, second path. Now what happens in this scenario, since we have not changing the AS value, so this is going to have 5, it's going to have 4, 3 and 1. So which one will be preferred? The shortest AS will be preferred. So this is 1 2 3 4, 4 AS numbers or 4 AS path, whereas here you have 5 4 2 and you just added up one more. So totally you have 5 AS path. And what is the definition for AS? It's your shortest that is preferred. Okay, so the shortest get preferred up. So by automatically this will be rejected, this path is rejected, and this will be preferred. This direction will be preferred. Okay, so that's AS, that's called as, or that's the functionality of AS path, which is fourth. Hey, sorry, I got disconnected. Give me a second to share my screen. Okay, so do you guys see my screen? And am I audible as well? Okay. It should be fine. It should be fine now. The voice should be fine now. Okay. Well, so yes, as I was talking about AS path, it's for incoming traffic. It's for incoming manipulation traffic, which is coming towards the enterprise. And the last one here, I mean last one for the day, not from the BGP point of view. I don't want to take all in one class. So in the last class we discussed weight. Today I'm going to discuss about local preference and AS path and MED. Okay, only these four from the incoming and outbound traffic manipulation. Rest we will discuss in the next class, but before that you guys have to do the lab which I'm going to discuss and understand the four attributes. Okay. Okay, regarding to MED. So do anyone know where do we see the attribute of MED? I mean, on which table can I see, or where do I see? Oh, so do you guys know which command is gonna show you MED? Okay, so MED in BGP is hidden in the metric word. Okay, okay, so let me just show you. I know you guys may not have understood. So this is MED. Yeah, so don't get confused with the OSPF and EIGRP metric. Okay, so you guys might be heard me telling that BGP don't consider metric, and now if I say BGP is having the word called metric, don't get confused. MED or multi exit discriminator is being referred as metric. Okay, it's totally different than metric. It doesn't have to do anything with the cost or anything. And what is MED? So let me tell you, let me show you one scenario. So let's say I have two router. Let's say this is enterprise. I have router B and router D, and for some reason I want to, if you see, I have multi exit path, right? So I can receive the traffic from here, and I can also receive the traffic from here. Similar way, you can see from the ISP side, you have the traffic over here, and you have traffic from traffic coming on the second router. So it's a multi exit where you need to decide which path you want to take it. Okay, once again the commands are very simple if you know on which direction you need to apply. So let me walk through the points first. So it's the sixth attribute. Okay, so as I told you, the incoming and the outgoing. Okay, so under incoming you have AS path and MED, and in the outgoing you have weight and the local preference. Okay, so we are talking about the fourth one, the MED, which is a sixth attribute. Okay, let me once again show you the flow chart. So over here, so the sixth attribute is this. So let's say all are set to default. We have not changed anything. Now you have an option to change the MED value and manipulate your traffic the way you want, and on which scenarios you will see MED. So you might be wondering why MED, why don't weight, or why not local preference, or why not AS path. Now these have some limitations, their own limitation. As I told you, weight is local to the router, local preference is local to the autonomous system, the throughout the autonomous system. AS path is something which is for incoming traffic. Okay, where you can prepend uh, adding, prepend is nothing but adding some dummy autonomous system, and to say that this is having 5 routes, so take the second route, which is what you want uh, after all. Okay, so med is a scenario when you have two exit paths. So let's say in this case you have two exit paths, right? So in this case you cannot play with AS value. How can you add some AS value, because they are directly connected? Neither you can add local preference because there are two different routers. Neither you can sorry, not local, wait, I'm talking about. You cannot make use of wait because there are two different routers. Similar way, you cannot go with local preference because you are dealing with eBGP scenario where you have two AS. So as soon as the packet come from one AS to other AS, your local preference is gonna be set to 0. So there are these three are getting failed in such scenarios. All three are getting failed. So only attribute that can help you is MED. Okay. So what kind of med is preferred? It's your lowest which is preferred. It's a non-transitive attribute. See, this is the plus point. Med is exchanged between autonomous system, right? This is how it's gonna help you. It's exchanged, whereas your local preference was not exchangeable. MED is used to advertise the neighbors how to enter the AS. So traffic which is coming in, I'm gonna tell how is the traffic, or how which path has the traffic to come. Okay, I'm basically telling my incoming traffic that I need on router 2, I don't need on router 1. So I'm gonna change the med value of this so that I receive here. Med is propagated to all routers within AS. So it's gonna, so you configure med, it's gonna be propagated to all other routers. Okay, med is also inter AS exchangeable. So that's how something which is coming from a different AS to my enterprise AS, that's how the med is gonna be going to work here. So MED is not passed along any other autonomous system. That is my traffic if it's going across some other AS. Now that's not my med is going to get forwarded. It's between these two AS only. My med will be not reflecting because might be I have a different traffic manipulation here. So if I propagate my med bit of this to this, now the whole concept of med will be failed, because I don't want my other part to be bothered because of the med change that I'm doing here, right? So that will be not propagated beyond R2. So it will be remaining between these two AS and within the AS, but it's not propagating to elsewhere. It can influence the routers, okay, but not on different AS. So that is what I said. So this is the logic for med. It's between routers, okay, it's between the routers. When you have direct AS connected, you cannot bring AS path concept in this because they are directly connected. Okay, so you have to make use of med, and the limitation of med is they need to be directly connected. Med will not be sent beyond this, so something like it is not getting propagated. Okay, how do we configure this? So let's say wherever you need wherever you want to change the behavior, you just need to set the metric. Okay, that's nothing but the med value. So increasing the med will make that path to be the second preferred path. Okay, and the best one or the first preferred would be the one with metric or med 0 value. So by default they are going to be 0 until you're gonna change. So what you need to do is So let's say in this scenario, okay, let's say I have two path and both by default are set to 0. Okay, I don't want this path. So what I do, I just make use of med 50. By default, what is preferred? The lower value is preferred. So by default, shortest get preferred up. Okay, so that's how you play around with med. So I have given you the commands that you need to make use of. Okay, so these are the four attributes from the manipulation point of view. Rest of the attribute, yes, they are important, but some attributes are automatically getting originated. Say for example, the way you configure will make them getting originated. Say for example, originate. This is something which you cannot change the behavior. If a route is originating internally or if from a externally, it's not in your control. It's the way they get originated automatically. Similar way, origin code. If a route is originating from IBGP or EBGP or OSPF or EIGRP, it's not in your control to manipulate. You will just have to cancel or delete the route. That's all, right? They cannot be manipulated, I mean to say. Okay, similar way, this one, do you think you can manipulate this shortest IGP path to BGP? That is the fact which you should know, and you should know what is logic behind that. It's not something manipulatable. You cannot change something in these kind of attribute. Similar thing goes with oldest path. Do you think you can change something on the oldest path or the newest path? You can just shut down and might be then relearn the route, but that's going to get the outage if you shut any route, right? So these are some attributes which you need to know, but at the same time they cannot be manipulated in order to just change your path selections. Okay, same goes with this. Do you think you can just change this often on a production? You cannot change this in production. I'm talking about a production network, not a build up network or a or something which is getting on from the scratch. Okay, if it is a day one of your network where you're configuring, yes, you can change the router ID, you can change the neighbor IP, so that you just do that basic path selection, because you know the lowest is preferred, the oldest is preferred, all those things you can do that. But I'm talking about from the operations point of view. Once your BGP is all set, now you have a lot of users, lot of traffic coming in and out. Now these are some attributes that you cannot manipulate. Something, see, these are the attributes you cannot manipulate in the production. Okay, so you're only left with this and this. So these are the important attributes which will help you to manipulate incoming or outgoing traffic, and depends on the scenarios. Okay, so it's not something you have to do all the four all the time. It's either one of them. So making use of one, you can just change the traffic. Only you should know is what is the direction of the traffic. Okay, is the traffic incoming to your enterprise? The simplest I would suggest is go with AS path. It's very simple. Okay, just add some dummy AS values so that you can take down one of the bad ISP and focus or send the or receive the packet from the other ISP. The AS path is very simple. It is for incoming I'm talking about. Similar way for outgoing, you know, you are only left with two options. One is wait and local preference. But at the same time, you know what are the limitation of wait. It's a Cisco proprietary. Now, let's say on my side, I have a Cisco box, but my ISP is running on Juniper. Okay, so do you think I can go with wait in this scenario? No. So just take local preference. So 99% is your local preference that's gonna help you. Okay, so I would say for outgoing, make use of local preference. For incoming, make use of AS path and go in very good knowledge on these two, which will help you to manipulate. Okay, so as I'm telling this, it's one every time. It's not all four that you need to bring up. Okay, but you should remember the other things, because these are uh, in a stepwise. Okay, so first, second, third, fourth, fifth till 11. So just don't think that only four are important, not the others, because when you go attend some interview, you gonna uh, tell all the 11, and you they should be in a flow. Okay, flow in the sense you start with weight and you end on neighbor IP address. So in between whatever happens, you must define it in a order. Okay, and yes, again, the next question would be, how do you manipulate incoming and outgoing, where you have to know what are they, and what is it, a shortest that is counted, or is it a local significant, or is a local AS significant, all those things. Okay. So this was regards to the path selection. The entire attributes, if you see the entire attributes, then it's over here. Okay. So under non-transitive, you have these many. Under transitive, these are ones. So a well-known discretionary, you have these many. Under mandatory, you have these many. Okay, this is the complete chart. This is the complete attributes. And for path selection, this is the flow. We make use of this as the flow. Okay, now coming back to the lab. Okay, so this lab I had configured, but unfortunately it got closed, and I think I lost a lot of configurations. Okay, so if you see now, I only have the initial configurations and nothing else. Okay, so on all the routers, I guess there will be only initial configurations. Okay, I have something here. Give me just a minute. Let me see what did I lose and what I do have. Okay, so the whole lab was about manipulating the path. Okay, so if you remember the previous class, I used this for manipulating and showing you uh, the weight attribute, okay, which is locally significant. If you have another router, then probably we cannot make use of weight. So that's the drawback of your uh, weight attribute. It's for the outgoing traffic I'm talking about. Okay, so if I want this interface or this, I can just change the uh, attribute. It's a neighbor basis. Okay, if I say neighbor 1.1.1, I can say weight is so and so, and just change the behavior. Now when we move on, or when we have such kind of topologies, when we have multiple ISPs, the ISP is connected to another ISP, and then finally we reach the destination. Okay, so this is the source and this is the destination. So what am I running here? So I am having EIGRP, a basic dynamic routing protocol. I have IBGP here. I have eBGP, another eBGP. Okay, the same goes over here. It's eBGP, eBGP, IBGP, 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 and finally eBGP. Okay, so you need to see you have reachability, okay, on this path and this path. That's your first goal. So you can just ping this loopback address. So let's say this is 8.8.8.8, okay, which is a Google server. So if you ping from this router 8.8.8.8, it must be reachable. You must be pingable. Same goes from this router. If you ping 8.8.8.8, this must be reachable. That is your first task. Okay, so as I told you, it's just about EIHRP here, and rest all IBGP and eBGP and whatever topics that we have learned. So you know that by default, when the when the routes are learned over here, you know that the next hop is not going to get changed, right? So basically this will still think that this is the forwarder. So over on these two, you need to make sure you have the next hop self configured. It's from the IBGP point of view. Okay, so whatever theoretical topic we have discussed, we are going to use. Yes, I am not bringing up multi hop. Okay, I'm not bringing multi hop and update source. I don't want to make it more complicated. So I have excluded these two topics, but you know what is multi-hop and what is update source. It's when you're considering BGP neighbors on loopbacks. Okay, even though I have mentioned loopback, I'm not making use of loopback for my BGP neighbors. I'm just going straight forward with the physical IPs. Okay, so these are not being done on this. I just want to show you the path manipulations. So by default, when you when you have configured EIGRP, and over here if you make a trace route, you can see the both getting considered, because EIGRP takes equal and unequal, and our case it's both equal. Do you see any reason for unequal? There is no unequal, it's equal. Okay, but there will be one path which will be best path. Uh, that's something which you need to decide from this point and this point. Okay, so let's say if the traffic is going on this way. Okay, so as you know, EIGRP is going to load balance. It will see, it will make sure both are getting considered. Okay, because from EIGRP point of view, both are good traffic, both are good directions, so it's gonna support both of them. So you, let's say you need to take down not take down this, you need to say this is not a good path and you want to prefer this. So as I told you, when we are talking about the outgoing direction, okay, so when I'm talking about outgoing direction, the first one is weight and second one is local preference. Okay, so by default local preference is set to 100. So by default this will be 100 and this will be 100. So which path do I need? I need this path, right? So I am going to make this as 110 and I am going to make use of this now. Now if you trace route, you will see that this will be the best path. Okay, so that's again something which I have mentioned here. So if you see the local preference, the only command that you need to do is you just need to change the local preference on the router. It's not a neighbor specific, it's a AS specific. Okay, so you just change it on the router and the IBGP that we are running here. Okay, the IBGP that we are running between the two routers are gonna keep the update. It gonna say that on this side I have 150 and on this side it's 100. So the traffic should be taken this. Okay, so that's for local preference. Now let's say you wanna change AS value. Okay, and if you see from the diagram, they're gonna be the same AS numbers. So 5421 531 or 5431. So basically both are same. So I can just change, I can say that I do not need this. Okay, so what can I do is I can just prepend some dummy AS values, something like this. Okay, I'm gonna bring up two new AS numbers, some dummy values which are not part of my diagram or not part of my whole design. It's some dummy values so that my whole AS values get added up this. So now as soon as I prepend to this network 1.3.2, that's in this scenario. Okay, so I'm going to add two dummy AS values, something like this. So totally it makes up to one. This is 2, 3, 4 and 5. So you have 5 AS values and over here you have 1, 2, 3, 4. Only 4. Okay, so 1, 2, 3, 4, 5, 6. You have 6 on this side. So as we know, AS path, the shortest is considered. So automatically the incoming traffic will be taken up on the AS values. Okay. And what is the configuration that you need to do? You need to write a route map. Okay, is similar to your access list. So we don't make use of access list, but we go with route map in case of BGPs. Okay, so I'm going to write a route map. This is the word I say prepending and I say permit 10 because this will be acting as a access list that I said I'm permitting. Okay, and I say set AS path prepend two AS numbers and then I'll make use of in the out direction. Now this is very interesting. When I talk about incoming traffic, I make use of the word out. Just take that, keep in mind. Okay, so when I have the incoming traffic, something in this direction, okay, my keyword goes as out. Now that's vice versa in the other condition, that is for the outgoing traffic. When I have outgoing traffic, something is in this direction and I'm making use of the route map. Now I'll be making use of the inward. Okay, so this configuration will bring you the dummy AS value. So you're just changing the behavior, and as you know, the lowest is preferred AS values. Okay, and for med, as you can see, you need multi exit value, something like this. Okay, so what I can do is I can just bring up one link from here, from this router to this, and I can create the med functionality, or I can see how the med works. Okay, so what is the command for med manipulation? So you just need to set a higher value. Okay, by default it's 0. They are 0. The metric is 0. Okay, let's say this is the lane. Let's say it's 0. You just need to add higher value on this to make it look like a bad traffic. Okay, so this gets preferred up, this path get preferred up. So med is lowest, that's preferred. Okay, so the lowest med is preferred. So this is something which I think you guys can practice during weekends. Okay, so you will be provided with the topologies, you will be provided with all the IP list and the initial configurations. I also have the configurations, but since it got uh, closed unfortunately just before the class, so there is no connectivity as of now from this, from CE2. So let me see what is the issue. Okay, so both are shown as ideal mode, so 10.3. Okay, so looks like that. Okay, so this is not good. Why is it not good? Okay, and I hope it's not a GNS bug or something. Even though they looks to be up, I cannot ping these two. So it happens sometimes that you do keep troubleshooting, but later on you realize it's a bug with the GNS. I'm getting this kind of bug. So looks like this is a issue with bug only. Show IP int brief. So I have one side connectivity. Okay, so what is happening? So if I do show you the trace route, so it's moving over on this 12.2, okay, and then it's forwarded to 2.2, 10.1.2. So how is my IP designation? I say 10.1.2. So 1.2 is nothing but 1 to 2. Okay, 1 to 2. So I see it's moving towards 1.2.2. So that's this one. And I usually take, let's say if this is the router, these are the routers. So I take the left one to be dot 1 and right to be dot 2. And if I am talking about from north to south, I consider this as dot 2 and I consider this as dot 1. So you will see that kind of IP designations. Okay. So traffic went to this from here to here. It was eBGP, and from here it's moving to 224. That's nothing but 2 to 4. Okay, and from here it's going towards this, which is dot 2, and finally from there it's going towards AS5 5.2. Okay, so if you see the BGP table, so you will see a huge list of AS values getting associated. Okay, so if you see show IP, okay, not here because this I don't have BGP here, but I can show you how is 8.8 read. Okay, so it's been going across on 12.2 because the other link over here, I guess it's a GNS issue or something. I need to check. Okay, otherwise you should have seen two path. As of now you see only one, so you should have seen two best path. And if I go to the C1, that's nothing but this router 12.2, that's this one. Okay, so which is C1 in my diagram, it's this one. Okay, where I am running BGP. So if I see show IP BGP table, so I have lot of prefixes. Okay, this is the Google prefix that I am interested. So the next hop is 10.1.2.2. Okay, I have not changed anything, so there will be no manipulated values. If you see the AS path, you can see 2 getting added up, 4 getting added up, and 5 getting added up. Okay, so this is how the AS path gets considered. Okay, so what else can we see? We can see show IP route. So from routing table, you can see it's a BGP read. You see it's a eBGP cost of AD value. Okay, and you know in case of BGP, it's not the cost that is important. We don't have the concept of cost, so it's 0. Okay, this is the next hop, and this is the timers for how long this has uh, been present. So this is how the oldest and the newest are getting compared. So this is now, let's say 2 hours. We know it for 2 hours, and if something comes up for 10 minutes, the oldest one is getting preferred. So there was one criteria where it says oldest is preferred when compared to the latest one, right? So this is show BGP summary table. So one of them is idle, which is C2. Okay, and I guess C2 is having a bug. So you see all the interfaces of C2 are flapping. So basically this is getting flapped. So I have to delete that and I have to bring up. If you see the interfaces, all interfaces are up, Okay, they are all up, but the neighbors are getting failed. So on one side, the EIGRP is getting failed, IBGP has gone into idle mode, and EBGP is also down. So basically, this is the culprit. Okay. Okay, so the traffic from C1, so let's see show IP BGP 8.8.8. Okay, so you will see the AS values, you will see all different parameters, local preference. This is the best path. Okay, and from here the traffic went towards the AT&T AS2, which where the label is where the router is labeled with P1, provider end. Okay, so over here if I do see the show IP BGP summary, so I have two neighbors, one on left and other one on right side. If I do see show IP BGP, my interested one, that is this one, so you can see the AS numbers, you can see the next hop, show IP BGP 8.8.8 is going to show me the details about this prefix. So every prefix will have its own attributes, and collectively what is that component that's gonna carry this information? So do you want to answer? So anyone remember what is that word which we use for uh, to take all the attributes with regards to one prefix? Let's say I have some other prefix, it will have its own attribute. I have some other prefix with me, let's say something. So basically, the prefixes or the attribute are associated with the prefix, and collectively we call a single word. If you remember, so no one remembers that. Yes, NLRI, right. So I'm just looking for the topic so I can tell you the slide number. Yeah, so slide number 88. Okay, which has the information about that NLRI. So I also had showed you the Wireshark, where I said that each NLRI is about each prefix, and each prefix will have its own attribute associated. Okay, and so once from CE2, from CE1 to AT&T, and from AT&T to the PE, provider edge third router over here. Okay, and from here if I see the BGP for 8.8.1, so you will see the behavior of AS values, you will see all other things. Okay, so they are by default, there's no change here. Okay, there's nothing changed here. And from P3 it's going towards P5. Show IP BGP. Okay, so this is your 8.8.8. So if you see one more thing, so let's say this is 8.8.8.8. Okay. So when you read 8.8.8. over here, what should be the next hop gateway? This should act as a next hop gateway. And when 8.8.8 is getting advertised on this, by default, what is the behavior of iBGP? It should have told, or it should have forwarded the same as a next hop gateway. On PE3 for 8.8.8, I must have seen the next hop to be this network, okay, 10.4.5.2, which is this IP. But that's not a good reason, because if you lose the IGPs like EIGRP or OSPF, and if you do not know how to reach this, then there will be the connection lost. Okay, so that to in order to manipulate that behavior, we make use of next hop gateway or next hop self. So what happens is, when 8.8. is advertised here, and when this router is advertising further to the iBGP peer, it's gonna say that I am your next hop gateway. You send me whatever packets, and then I will take care of it. So from my uh, BGP table, you see this 8.8. is saying that the next hop is 102.2. Okay, so what is that IP? That's over here. So I'm over here. Okay, and from P3 point of view, 8.8.8 is 8.8.8 says this is my next hop, and then this router is gonna take care of sending it to the destination. Okay, and I achieved this because I'm making use of the concept that I just discussed. Okay, the next hop gateway. So if you see this, I have added up the line. Okay, so I'm gonna say that this neighbor, okay, this is my neighbor 102.2, and he is my next hop self. This is the neighbor, and I'm going to send whatever packets or whatever 8.8.8 to this, and then he is gonna take care of it. Fine, so that's all from my side, and let me know if you have any doubt regards to what protocol I am using. Okay, I wanted to show you this full functional one, but this router, unfortunately, it went to some bug or something. I can see there are a lot of uh, packets originating. So even though they say the interface is up, but they are not. Okay, they are not working actually. So this one particular router, C2, rest are all working. Okay, I'll also give you the commands, so that's not an issue. Might be I'll give you the show running configuration from all of them. Okay, and I'll give you the topologies, so you can practice especially practice the configurations. Second thing, understand the packet flow by doing trace route and checking the BGP neighbors, all those things, and like how the next hop is working, all those things. Then try to manipulate AS path, try to manipulate the local preference. Okay, and for med you just need to have one more connection here, and for weight there is a separate topology which you can use it. Okay, so this one should be helpful for you to configure from configuration point of view. Okay, so let me see, the some had some doubts regards to configurations. Configure EIGRP. So EIGRP is running on this. Okay, not between this. Not between this. This is IBGP. So this is IBGP. So basically, let me redraw. Uh, this is EIGRP and this is EIGRP. Fine. Whereas this one is IBGP. Okay, regarding out and in, that's with respect to the traffic flow. Okay, and why do we make use of route maps? Uh, is so let's say I have 10 network and I just want to change the behavior for 5 of them. Okay, so with the help of route map, I can just select those networks. I can set the metric and then I can map those route map word with the neighbor. Okay, so usually I just straight away cannot go to the neighbor and I can define the metric so and so. So I need to make use of the route map. So the first thing is to define the values that you are gonna set. Once you define this, then you have to call it, and once you call it, you have two ways to call them, whether in or out. Okay, now it depends on the direction. So let's say the direction was for incoming. Okay, incoming traffic. So let's say this is my router. So this is the out facing and this is the in facing. So my route map will be now pointing towards out. So let's say this traffic will first hit the out direction. So let's say that's the reason we call it as we say the incoming traffic to be added up with the outward. Similar way, when I have, let's say this is my customer end and this is my provider end, and the traffic is going out. So while going out, this is the in and this is out, right? So where is it hitting first? It's first hitting on the in facing. So in such cases, route map will be pointed on in. So might be this way you can remember the in and out getting associated. Okay, so when you have med, it says out because med is for incoming traffic, right? So when you have med, which is for incoming, where is it hitting first? It's hitting on the out direction. So that's why you just can remember that it's a out keyword. The keyword out will be used. Similar way for AS prepending, it's added up with out. Okay, so let's say this is my router and I'm talking about or manipulating about incoming traffic. So the incoming traffic will first hit the outside facing. For local preference, we have the straightforward command. Okay, we don't have to set the direction because this is locally significant to AS value. It doesn't have to be uh, set in terms of incoming or outgoing. It's not between the, in the case of local preference, traffic is not moving across two AS values, right? It's not moving across two AS values, so you don't have to deal with in and out. So in the case of local preference, it's within the AS value. So if you set on one, so your parameters or the attribute will be transmitted to other routers, BGP speaker routers. Okay, So in this case, you don't need in and out. It's only when uh, you have AS path or the med, okay, where your AS are getting forwarded from one AS to other. So that's where you need this. But yes, local preference also, you can make use of route map. You can make use of route map. And if you make use of route map, then yes, you need to know how are you going to apply this in and out. So if route map is to deal with outgoing traffic, in that case make use of the word in. Okay. Okay, so what else is over here? NLRI, EIGRP is not configured on all interface. So I am making use of EIGRP over here and over here. That's all. I don't think we need EIGRP here. So basically, I have a IBGP between here just to send the attribute. I don't need any network that has to be advertised. My topology or my network is about from this loop back to this loop back. Okay, I just need to see the path manipulation. It's not about advertising EIGRP and flooding a lot many network in the EIGRP table. So it's about the BGP manipulation, how the BGP traffic is getting manipulated. Okay, even though you can just exclude this or you can exclude EIGRP. Okay, you might be you can keep a hub or some or let's say a computer over here, or let's say a small switch, and behind a switch you have a computer. So why do we even need EIGRP in this case, right? I can straight away give a static route on both, and then I can see on which direction the path is taken up, right? So basically BGP is deciding on which path, and changing the BGP attribute, the path will be selected up, right? This is just because I don't want static route, or I can go with one more protocol to show or demonstrate it easily. Okay, so I don't need EIGRP between these two. It's not really important. So if the link is going down, if you're talking from the production point of view, so you have other protocols like HSRP. Okay, EIGRP or OSPF is not really required in such scenarios. You have HSRP which will take care of the link. Yes, this is not required, in fact. So this link is actually not required, but I am doing it from the point of IBGP. So you can see the behavior of IBGP. Okay, so if you're talking about this point, it's because whatever routes you are advertising, okay, the first criteria is that that must be read over on IGP, and then you have BGP coming in. Okay, where is where your BGP will understand. If there is nothing advertising, you can still make use of a null interface, or you can make of a static route, and then BGP is gonna learn that. But I am not talking about the production point of view. This is not a production lab or something. This is for path manipulation. You're getting my point, right? I'm talking about path manipulation. I'm not trying to advertise my network, and I'm not trying to see how the BGP is reading the network, or how is it getting advertised. It's about path manipulation. You need to change attributes, and you need to see how the traffic gets rerouted. That's the main concern of this lab. So don't go ahead of what is expected from this. So this lab topology is for path manipulation, not about advertisement. Okay, I got your point. You're talking about from the production point of view. If you have 10 networks and if you want to advertise it over on BGP, you're looking for a full IGP scenarios so that BGP can learn them. It can. I'm not talking about from that point of view. It's a path manipulation. It's very simple with respect to configuration, and then change the path. Okay, so path manipulation is something which you need to understand. Like what happens if you change local preference here. Okay, the traffic is moving there or traffic is moving on this. So that's the main concept here. Okay, which is a topic in your NRC of uh, troubleshooting the path manipulation, path selection, how the path selection happens. All right, guys. So what uh, things do you need from my side to get this going? I mean, I'll be giving you the latest topology and initial config, and yes, the class notes which will help you. So I guess you guys should be able to get it going, right? So I'll also send you the running configuration of each one of them. Okay, so where is Rome? Okay, and what do you want to add? You want any additional routers here? Are you guys on mute? Okay. So you need any additional routers?
Uh, can you hear me?
Yes.
Yeah. You remember last time we was like between Mumbai R2 and Rome 1, we had configured stub, and those stub that area when you configure stub, it prevents LSA 5s, you know. And so you wanted to also uh, configure NSSA to, even though this link had prevent LSA 5s, you wanted that R2, which is an area border router, to convert those LSA 5 to LSA 7, but we couldn't do it because this was a stub area. So in the next class, you added a router that extended from ROM um, 01, and you added another router that that's adjacent to ROM, so that we can practice the
Okay.
LSA 7.
So I guess I have added up over here. I made the.
No, no, no. We're not. No, no. It was here. It was here. It was in the ROM section.
Oh, okay.
You yeah, it was in the ROM.
I
No, there was another router that stands from ROM, not from R2 mobile.
Okay, so you can have this acting as NSSA, which will create LSA 7, and the ABR will translate 7 to 5 back, and then there is how you can still get the 5 over here. That is for NSSA. So you want one more router over here, or where exactly?
But you remember you had that router, Rome router, the Rome router. There was another router attached to it
Something like this.
because yes, exactly like that. And then there was a stub between R2 and Rome,
Okay. Yeah,
and we
I can add one, and I can give you that. Okay. But as far as I remember, I think I made this as NSSA to suppress the 5 and bring up the 7. And so this router reconverted to 5, and then that's how you got all the external routes. But yes, if you think you need something here, might be I'll add one more router and give you the updated topology.
okay.
Okay, great.
I will show you. I will
Okay.
ping you the
Yeah, great, great. Okay, guys. So I hope that's all from uh, this class, and let's meet up in the next class. Okay, that's on Monday, and keep practicing and let me know if you're stuck at certain point. Might be I'll guide you. Okay. So have a nice day. Have a nice weekend, and see you all on Monday. So thank you for joining.